The next thing that we'll talk about is the idea of a recursive definition. So recursive definition is a way of defining a set. It's also called an inductive definition. You'll see that particular term sometimes. Um, and what you do in a recursive definition is you define a set by giving a procedure for constructing all of the members of the set. So it's a procedure for going through and establishing what all the entire membership of the set is. And it will have three parts. The first thing that you have is a base case, which just stipulates certain things that fit the definition. Um, then you have an inductive step, which gives a rules. Well, it may just be one rule, but often you'll have multiple rules here, where there are rules for taking something that fits the definition and then turning it into something else that fits the definition. And then you have a proviso at the end uh, that basically just says that this definition is complete, right? That only things that fit the base case or that can be constructed by the inductive step fit the definition. So you've hit all the cases between these two. Okay, so for an example, here is a recursive definition of human. Um, Base case is Adam and Eve are humans. Then the inductive step is the children of any humans are humans. And then we have a proviso, nothing else is a human, right? So chimpanzees don't count as humans, gerbils don't count as humans, right? Whatever other things you have don't count as humans. There are certain theological assumptions that are being made here, but if those theological assumptions are correct, then this definition does pick out all and only the humans that have ever lived. Um, For another example, here's a recursive definition of positive integers. This is actually like the standard way of defining the set of positive integers. Um, you start with your base case, you stipulate that one is a positive integer. And then in the inductive step, what you say is that if you have a positive integer and you add one to it, then the result of that operation is also a positive integer. So one is a positive integer. If you add one to one, then the result of that, which is two, is also a positive integer. If you add one to two, you get three, which is a positive integer, and so on and so forth. And between those, yeah, you define the entire sequence of positive integers. And then you just have your proviso, right? Nothing else is a positive integer, right? So, ham sandwiches and 3.5 and -4 and all of those, none of those count as positive integers.